Good evening, everybody. Mr. Sheehan here. We're going to go through our notes for the evening on imaginary numbers. Now, I know you're excited. I know this is going to be a great time, so we're going to get right down to it. We're going to start out talking about how to solve these two equations here. So the first one, you should notice we have the difference of two perfect squares. X squared is a perfect square, 1 is a perfect square. So we want to go ahead and we want to factor that into our two pieces. So we want to have our x plus 1, our x minus 1, and that's equal to 0. So if you factor t by that, you should get x equals negative 1 and x equals positive 1. For the second one over here, we can't factor that because, as we know, 3 is not a perfect square. So a second way to do these kind of problems is to go ahead and get the x squared all by itself. So we're going to add 3 to both sides, and we will get x squared equals 3. Now, in order to get rid of a square here, we want to take the square root of both sides, and you'll end up with x equals, and you always have to remember that when you're taking a square root like this, you want to do plus or minus 3, square root of 3. Okay? So, those two should just be review. This next one here is where it gets a little tricky. We want to solve the equation x squared plus 1 equals 0. Now that's not the difference of two perfect squares, so we can't factor it, but we can try the other method. So if we subtract 1 from both sides, you'll have x squared equals negative 1. And we want to go ahead and square root that now. And this is where the issue comes in. We have, right here, a square root of a negative number, which most of you know, as we've said in the past, this equation has no real solutions. There's no real solutions to that. What we have to do is figure out some other way to come up with an answer, because obviously we have that written down. There has to be something we can do. So we've said that has no real solutions, and we need to extend our knowledge. An equation like this will have a solution if we extend the number system beyond the real numbers to include numbers like the square root of negative 1. These numbers are called, wait for it, imaginary. And we're going to change that period to an exclamation point. Why? Because we love math. These imaginary numbers take care of square roots of negatives. So that cutoff part there just says we. We represent the square root of negative 1. We use what is in lowercase I. This is called the imaginary unit. So that imaginary unit is a lowercase I. And if you think back to your time in math so far, a lowercase I is never used as a variable. And if someone did use a lowercase I as a variable, they are not doing very good mathematics, because it's actually not a variable at all. It's the square root of negative 1. It works like any other variable, but since we know what it equals, we can simplify some powers of I. So we know that we're using I to represent the square root of 1. So I squared right here is going to be the square root of negative 1 times the square root of negative 1, which, as you know, if you multiply those together, multiplying square roots of the same thing, that's just going to give you a negative 1. So I squared equals negative 1. I to the third, if we break that down a little bit, we know it would be I squared times an I, right? So that means we know that I squared is a negative 1 times I. So this is actually just negative I. So I squared becomes negative 1. I to the third becomes negative I. Now we're going to figure out I to the fourth. Well, I to the fourth is really I squared times I squared, which is negative 1 times negative 1, which, as any sixth grader can tell you, is just a positive 1. So we end up with I squared being negative 1, I to the third being a negative I to the fourth being a 1, and now we're down to I to the fifth. And now you're going to see something really neat happen here. I to the fifth, we could break it down into squares and all that good stuff, or we can say that I to the fifth is really I to the fourth times I. Well, we just figured out that I to the fourth is a positive 1, so this is going to be positive 1 times I, which is just I. Guess what happens with I to the sixth? That is I to the fourth times I squared. So if we look back up, I to the fourth is positive 1, I squared is negative 1. So this is going to be a positive 1 times a negative 1, which is just negative 1. Okay? I'm going to go over to the side here and draw something else in. We already filled in that top part, I to the seventh. If you'd like to do that on your own, feel free. We can check it in class tomorrow. If we look at these in a table form, though, and I'm going to breeze through this really fast because we just did it. So we said I to the 0 is 1. We said I to the first power is just I to the second power is negative 1. I to the third power is negative I to the fourth power, which is what goes here actually, I to the fourth, ends up being 1. I to the fifth is I to the sixth is negative 1. I to the seventh is negative I to the eighth, that's right, is 1. I bet you can guess the rest of them. Okay, so this follows a pattern. I'll give you a second there. All right. The other way that you can do things, in case you have a huge number, like let's say we want to figure out what I to the 401st power is. We want to figure out what does that equal. You can actually take and divide that. We're going to do a little long division here. So you're going to take 401 and you are going to divide it by 4 and see what your remainder is. Everyone remember remainders back from like 3rd and 4th grade? So long division, I know it's a rusty skill, but 4 goes into 4 once, which is 4. We subtract, you get 0, bring down your 0. 4 goes into 0 0 times, which is 0, and bring down our 1. Now 4 does not go into 1, so we say that it goes in 0 times with a remainder of 1. That means that I to the 401st power is the same thing as I to the 100 times I to the first. Well, I to the 100, that disappears, it turns into just 1. And our remainder is I to the first power. So this whole thing equals I. Now, I know this is a little confusing. Once you wrap your head around it, though, it gets a lot easier. The last thing we want to look out for, look out with this crazy little person over here. The square root of AB is the square root of A times the square root of B. That is not true when you're dealing with negatives. Okay? This example here shows us that the square root of negative 1 times the square root of negative 1 is not actually equal to positive 1. That does not work out like that. Okay? This is I times I, which is I squared, which is negative 1. So you need to watch out for that. You cannot use the product property, when you are dealing with negatives. Okay? We're going to go on to a couple of examples here. So, starting with the square root of negative 4 plus the square root of negative 9. We're going to go ahead and break that down. The square root of negative 4 is going to be, if we break it into two pieces, will be the square root of 4 times, having some difficulty here, times the square root of negative 1 plus the square root of 9 is the square root of 9 times the square root of negative 1. Now we have some like terms. We can simplify that down a little bit more. I'm going to go ahead and change my color here. So we'll have 2 square root of negative 1 plus 3 square root of negative 1, which ends up being 2 plus 3 is 5, square root of negative 1. But we can't leave that radical like that because there's a negative underneath it. And we know that negative 1 is really just 5 times I. The second problem here, instead of adding, we want to multiply. But remember, you can't use the product property. It does not work. We want to break this down again. Well, we know that the square root of negative 4 is actually the square root of 4 times negative 1, the square root of negative 1, times the square root of 9, square root of negative 1, which ends up being 2i times 3i, which gives us 2 times 3 is 6. I times I is I squared. And we know that I squared is actually a negative 1, so this is going to be 6 times negative 1, which is just negative 6. Okay, like I said, this stuff does get a little easier the more you work with it. It's just like any other variable. If it was an x, you'd be doing the same thing. The only difference is you can change it into some numbers along the way. Looking at number 3, we want to simplify that down. So, we can't do anything but the square root of 6. It's going to stay as the square root of 6 times, now, negative 18 can be broken down into the square root of 9, the square root of 2, and the square root of negative 1. So if we simplify that out, we're going to have the square root of 6 times 3. This negative 1 can come up to the front here and turn into an I. The square root of negative 1 is I. And we're going to have our square root of 2. So we now have 3i square root of 2 times the square root of 6. Well, the square root of 2 times the square root of 6 is going to be 3i square root of 12, which can then be broken down into the square root of 4 and the square root of 3. So we have 3i square root of 4 square root of 3, which is 3i. I know I'm going into the symbol here. Times 2 radical 3. And I'm just going to draw an arrow so that you can actually see this so it's not behind that stupid logo. We have 3 times 2, which gives us 6i square root of 3. I know that kind of got in the way there. I apologize about that. I'm too cheap to buy the full version for $5. So I will stick with that logo there as long as I possibly can. Last one on this page is number 4, which is negative 1 over 16, all under the radical sign. So we want to go ahead and break that down. We can break it down into the square root of negative 1 over the square root of 16, which ends up being I over 4. So you can leave it like that. That one's pretty simple. Or you can write it as, a little bit better way would be 1/4 I. Either one of those is acceptable though. You can either use I over 4 and leave it there, or you can have 1/4 I. Both of those work. Okay? These next couple here are going to be pretty quick. We want to figure out exactly what each one of them equals. There's no simplifying radicals. There's none of that crazy nonsense. This is actually coming straight from this right here. Figuring out what the remainder is. Oops. Figuring out what the remainder is here when you divide it out. Okay? So if you have a small enough number, you can use that circle I showed you before. But if you got kind of a bigger number, you might not want to do that. So, starting with I to the 25th power. Well, we're going to do 25 divided by 4. 4 goes into 25 6 times, which is 24. You subtract and get a remainder of 1. So this is the same thing as I to the first power. Pretty straightforward. I to the 15th. Well, we're going to do the same thing. I'm going to go all the way over here, though, so that we have a little more room. So I to the 15th, you want to do 15 divided by 4. Well, 4 goes into 15 3 times, which is 12. You subtract and get a remainder of 3. So this is really I to the third power, which if you look back from your notes on the previous page, I to the third power is negative I. This is where it starts to get tricky, because 98 is a bigger number. So we have 98, and we want to go ahead and do 98 divided by 4. 4 goes into 9 twice, which is 8. You subtract and get 1. Bring down your 8. 4 goes into 18 4 times, which is 16. You subtract and get a remainder of 2. So this is the same thing as I to the second power, which is just negative 1. Sorry, I should be boxing all these answers so you know exactly what they are. I'm going to take I to the 36 out here again, and we're going to do 36 divided by 4. Well, 4 goes into 3 0 times. 4 goes into 36 9 times, which is 36. Subtract, you get a remainder of 0. So this is the same thing as I to the 0 power, which is just 1. Anything to the 0 power is 1. Last two are a tiny bit trickier because now we have to do a little bit more simplification. When you multiply 2i to the 7th times 5i to the second power, you multiply 2 times 5, which gives us a 10. I to the 7th times I to the second, you're going to add those exponents and get I to the 9th power. So when we figure that out, we know that 4 goes into 9 2 times with 1 left over. I'm not going to show out the division because that's kind of a simple one. So this is really the same thing as 10 I to the first power, which is just 10i. And the last one, the trickiest one of all. We have 3i to the 22nd squared. The whole thing is squared. So you want to make sure that you square everything there. So 3 squared turns into a 9. I to the 22nd raised to the second power means you multiply. So this is actually going to be I to the 44th power. And I'm hoping that you notice that 44 divided by 4 is exactly 11 with no remainder. So that means this is going to be 9 times I to the 0 power, which is just 9. I went through that pretty quick, I know. If you need to go back and listen to some of it again, that's probably a good idea. We are going to do a significant amount of practice on this because the more you do it, the easier it becomes, especially the problems here. I will see you in class tomorrow. Have a wonderful evening.